Hi, this is section 6.3, the addition and subtraction formulas. So they start us off with cofunction formulas. So the way you can think about these formulas here, cofunction formulas, if you think of a right triangle, let's call the angle U. So sine of U, let's just look at this one as an example. The sine of U is going to be opposite, well, I should just call it ABC, actually. ABC. So the sine of U, if we're looking at the first example, is going to be opposite hypotenuse, so A over C. So that's A over C. Well, let's find this angle. Well, because the sum of the angles have to add up to 180, this is really 90 minus U. This is 90 minus U in order for the three angles to add up to 180. All right, so this would be 90 minus U, which is the same thing as saying pi over 2 minus U. So now we know this angle, and if you take the cosine of that angle, you're looking at adjacent over hypotenuse, which is the same thing, A over C. And the same concept applies to the rest of these. All right, so now we have the addition subtraction formulas. So these are just formulas that you can either memorize or you can just use your formula sheet to reference, or you can use the notes to reference. And there's tangent ones as well. All right, so for the first example, they want us to express this as a cofunction. So cofunction, that means we need to use these ones up here. So the one that would apply to this specific problem is cosine of U. So we're going to use this one here. So let me copy and paste that. Okay, here it is. All right, so clearly U is pi over 3, so you substitute pi over 3 for U, and you're going to get sine of pi over 2 minus pi over 3. And the common denominator would be 6. So we're going to multiply top and bottom by 2 here, top and bottom by 3 here, and you're going to get 3 pi minus 2 pi, which is 1 pi, and that is our final answer. So we've expressed cosine of pi over 3 as a cofunction of a complementary angle, and that is it. All right, let's move on. Find the exact values. So you want to look at the angles, and if you recognize these angles that are angles in standard position on the unit circle, then you can just determine what the values of these are by looking at the unit circle. So the cosine of pi over 4 is radical 2 over 2, and the cosine of pi over 6 is radical 3 over 2. So we have radical 2 over 2 plus radical 3 over 2 equal to radical 2 plus radical 3 over 2. And we do not want to use our calculators because they're asking for the exact values. Exact values, this would be the exact value, whereas the approximation would be the decimal that you would get from a calculator. All right, the next problem, same thing. I recognize these two angles that are angles in standard position on the unit circle. So tangent of 60, here's 60. If you take the y divided by the x, you're going to get radical 3. So that is radical 3 plus tangent of 225 would be, 225 is right here. The tangent is y divided by x, and negative divided by negative is a positive 1. And so that is the final answer. Next page. So these problems come up a lot, so you really want to understand these type of problems. So they're telling you what sine alpha is equal to, and then they're telling you that tangent is positive, and then they want us to find the exact value. So whenever you have this kind of situation, you always want to draw a triangle in the correct quadrant. Well, because tangent is positive here and here. So we can eliminate these two quadrants, and then they tell you that sine is negative. Sine is negative here, not here. So now we've figured out which quadrant our angle lies in. So we can draw our triangle in that quadrant, right triangle, and the angle is alpha. This is opposite over hypotenuse, so opposite over hypotenuse. Notice I put the negative with the 5, not with the 13. Hypotenuses are never negative, only the sides can be negative. And this one's going down, which tells you it should be negative. All right, now we need to find the missing term. Well, to find the missing term, you can call it a, and then do a squared plus b squared equals c squared. And the answer is going to be negative 12. So a squared plus b squared equals c squared. That's the Pythagorean theorem. That's how you find the missing side. Notice it's negative because you're going left. If you would have been going right, it would have been positive. So now that we've found the three sides, now we can find the exact value of that. This is a difference formula, so we have to use our formulas. So here it is. The difference formulas is this one. Whoops. This one. So sine, cosine, minus cosine, sine. So sine cosine minus cosine sine. And I replaced the the beta with pi over 3. All right, so let's see. For the first sine alpha, we use our triangle, opposite hypotenuse, or you can see it's already given to us. So negative 5 over 13. Cosine of pi over 3, we know that from our unit circle, cosine of pi over 3 is 1/2. Minus cosine of alpha, we use a triangle, adjacent over hypotenuse. And finally, sine of pi over 3, unit circle, the y-coordinate is radical 3 over 2. All right, now we need to simplify this. This is going to be negative 5 over 26. Double negatives plus negative times a negative. And we have, that's going to be 12 radical 3 over 26. Common denominator is there already. So I'm going to rewrite this as 12 radical 3 minus 5. That is the exact solution. I believe I skipped a problem. Yeah, I did skip one. So let's go back to these down here. Notice that this is cosine sine minus sine cosine. So that would be cosine sine minus sine cosine. So that's going to be this one. Sine u minus v. All right, so we got to figure out which one's a u and which one's a v. Well, it looks like cosine, this one is v, and this one is u. And then this one is u, and this one is v. And they do match up. U is the same number, v is the same number. So now we can use the left-hand side to substitute u, 82 for u, and v, 61 for v. And if you subtract, you're going to get sine of 21 degrees. So they did want us to write this as a as a trig function of one angle, which we've done. All right, the next one, this one's a little bit trickier. Notice that you have negative angles. Well, recall that sine is an odd function, and cosine is an even function. So we can apply that here. Sine is odd, so this becomes negative sine of positive 5. And sine is also odd, so this is going to be negative cosine 5 sine of positive 2. So this negative came out, and I just moved it here. and this negative came out, and I moved it here. So since I have two negatives, what I'm going to do is I'm going to factor out the negative. Now I have sine of 5 cosine of 2 plus cosine of 5 sine of 2. And now I can select the appropriate formula. Sine, cosine plus cosine sine is sine, cosine plus cosine sine is sine u plus v. So the u is the 5 and the v is the 2. And so therefore it's going to be negative sine of 5 plus 2, which is negative 5 of 7. And that is the final answer. So notice that once I factored out the negative, it just stayed in the front, stayed in the front, stayed in the front. And that is it. So now let's go down to this problem here. So if alpha and beta are acute angles, so that's key. They're acute. So when we draw these triangles, we can draw them in quadrant 1 because acute means between 0 and 90. So we're going to have to draw two triangles, one for alpha, one for beta. And we know that they're both in quadrant 1. So here's the alpha. Whoops. Alpha would be somewhere here. Beta is also going to be somewhere here. All right, now we're going to use our knowledge of cosecant, which is hypotenuse over opposite. So hypotenuse over opposite, and cotangent is adjacent over opposite. Adjacent over opposite. All right, well, this is a 3, 4, 5 triangle, so I know that's 5. You can use the Pythagorean theorem to verify that. This is going to be a 5, 12, 13 triangle. You can also use the Pythagorean theorem to verify that. A squared plus b squared equals c squared. All right, once you've gotten that down, now we can figure out what these are equal to. We're going to use the formulas. The formula for sine is sine alpha cosine beta plus cosine alpha sine beta. And we just use our angles to fill in each of these ratios. So sine alpha is 12/13. Cosine beta, adjacent hypotenuse, 4/5. Cosine alpha, adjacent hypotenuse. And sine beta, 3/5. All right, the LCD is 13 times 5, which is, what is that? 65, I believe. And then we have 48 plus 15. 48 plus 15 is 63. So our final answer is 63/65. All right, the next problem, we need to use a tangent formula. So I'm going to copy and paste that one. Here it is. Copy and paste. Here we go. All right, so we already have the triangles drawn out, which is great. So tangent of tangent of alpha. We just change these to alpha, beta, alpha, beta. Tangent of alpha is opposite hypotenuse, so that's 12/5. Plus tangent of beta, 3/4, over 1 minus 12/5 times 3/4. So let's see if we can do this. So it's just arithmetic at this point. Well, we know 4 goes into 12 3 times. So that's going to be 9. That's going to be 9/5. And then 1, I can convert 1 to be 5/5. So I just changed this to a 3. 3 times 3 is 9/5. Instead of 1, I'm going to call that 5/5. So I have a common denominator. Over here, I have the common denominator will be 20. So times 4 times 5. So I have 48 plus 15. 48 plus 15 is 63. And so now I have 63 over 20 times the reciprocal. The reciprocal of the denominator is negative 4 5. The reciprocal will be times negative 5 fourths. All right, well, let's see. 5 goes into 24 times. And so now we have negative 63 over 16 as our final answer. All right, let's see. So now they want us to figure out which quadrant contains alpha plus beta. Well, we have two acute angles. So an acute angle plus an acute angle. It could be in quadrant 2. It could be in quadrant 1. We can't be really for sure unless we, what I would recommend is you can take either one of these answers and take the inverse sign for this one. So in other words, inverse sign, so sine of alpha plus beta is equal to 63 over 65. You can take the inverse sign of both sides. Well, on this side, you get the signs to cancel. So you get the sum of alpha plus beta is equal to the inverse sine of 63 over 65. So on your calculators, if you're in degree mode, it might be a little easier. So second sine 63 divided by 65 is 75.7 degrees. So plus beta is approximately 75.7 degrees, and the way I found that out is by doing the inverse sine of 63 over 65, and this is what I got. So that would be quadrant 2. So quadrant 2 is the final answer. All right, now we're verifying identities. So once again, we need to use the formula that we just used earlier. I'm just going to write it out. And of alpha plus beta is equal to tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. So that's what we're going to use. We're going to start on the left-hand side. So the left-hand side, we're going to use a formula, but replace the alpha with the u and replace the beta with pi over 4. So we have tangent of u plus tangent of pi over 4 all over 1 minus of u times tangent of pi over 4. We know that tangent of pi over 4 is 1. You can verify that on your unit circles. So this is just 1, 1. So now we have tangent of u plus 1 over 1 minus tangent of u. And because addition is commutative, that means you can reverse these two, and essentially it's the same thing as 1 plus tangent. So at this point, we can just say that's equal to the right-hand side. All right, the last problem involves the sum and difference formula. So let's write out the sum formula first. So left-hand side, the sum formula for that will be sine u cosine v plus cosine u sine v.